Hey everybody, Jake here coming at you with another math lesson today. Doing it live again this week. Happy Monday. Hope everybody's Monday's going well so far. Been going over a lot lately about different methods for taking derivatives of functions, and I wanted to keep going on some of that. So we're going to talk some more today about using the product rule. And I wanted to show you a few more product rule examples that are a little bit different than the ones that we've been doing in some of my other recent videos and live streams. Before we jump into that, I do want to mention product rule and, in fact, also some of the components of the examples we're going to be going over today. How to find the derivative of those specific little components of these functions are on my Calculus 1 study guide or my differential calculus cheat sheet. They are also talked about a bit in my complete Calculus 1 package. So if you want to check out either of those, the link is down in the description below or the pinned comment if you're watching this later on. Also, as with any of these live streams that I do every week, if you have any questions along the way, feel free to drop them in the live chat. Even if it's not about the example that we're talking about or even about the topic we're talking about. You know, if you got some questions that is not about product rule, throw them in the live chat. I'll do what I can to help answer those for you. If I can't answer them live, maybe I'll make a video about them later on and answer your question then. So whatever you got, throw it in the live chat. We'll see what we can do for you. But without further ado, let's go ahead and jump into these product rule examples that I got for you here. So first one here, we're going to find the derivative of y equals x cubed times log base 2 of x. So as with the other product rule examples that I've talked about, really when you're doing any product rule problem, and this is going to be the case for any product rule example or any product rule problem, you really just need to figure out what are the two basic components of the function that you're taking the product of. So in this case, it's pretty clear based on the fact that we have this multiplication sign here. There's two components that we're taking the product of. We are multiplying x cubed and log base 2 of x. So essentially, you just want to call one of those one of your functions and one of those your other function. F and G are probably the two most common letters you'll see for that. It really doesn't matter what letter you call it. What's important is that you know which are the two components that you're taking the product of to get this full overall function. So in this case, it's going to be x cubed, and it's going to be log base 2 of x. Then the product rule says that we need to find the derivative of these two things. So in this case, if we're calling this f, we would need to find f prime, and if we're calling this g, we need to find g prime. So the derivative of this function here, x cubed, that's pretty straightforward. We can do that just using the power rule, which is also on my Calculus 1 study guide. You basically would just leave your base x as x. You bring your power down in front. So you would bring your 3 down in front of the function, making it a coefficient, multiplied by x, and then subtract 1 from your power. So lower the power by 1, giving us 3x squared. Now for the derivative of log base 2 of x, that is a little bit weird. Well, I don't want to say weird. This specific thing, basically how to find the derivative of log base a of x, is one of the formulas on my study guide. How to actually do this, though, if you don't want to bother with memorizing a formula, what you want to keep in mind is one of the log properties is that you can rewrite any log where you have log base something of something else. You can rewrite it as a different logarithm where you have whatever base you want, and well, let me rephrase that. You can rewrite it in the form of other logarithms that have whatever base you want it to have. So log base a of x can be rewritten as log base whatever you want. So let's just say log base, no, let's not say y. Let's say log base b of whatever you're taking the log of, so in this case log base b of x, over log base b of whatever your old base was, so in this case a. So basically the base of these two logs is the same, and then you have, what was your base is now the log on the denominator. What was what you're taking the log of is now what you're taking the log of on the numerator. So how you can easily remember this is whatever is kind of lower here, whatever's your base, whatever's written lower goes on the bottom of the fraction, whatever's written higher goes on the top of the fraction. The base then becomes whatever you want. You just need to make sure that the base of these two logs is the same. So as long as this b is the same on both these logs, this will be true. And what that tells us is instead of taking log base b of x, we could say log base e, the known, Euler's number e, which is roughly 2.71. But that's not really, important what that number is. What I'm trying to get to here is that log base e is the same as natural log. So basically this is natural log of x over natural log of a. So now what you want to kind of notice is natural log of a is just some constant. A is just whatever this base is. In this case, we have a equals 2. So what we can do instead of saying a here, we can just write log base 2 of x. And then this would be a 2. So basically log base 2 of x is the same as natural log of x over natural log of 2. Well, since 2 is some number, 2 is a constant, natural log of 2 is some number, right? We could plug natural log of 2 into a calculator and get some number out. What the actual number is not important, because what we want to think about is how do you take the derivative of natural log x over natural log of 2? Well, what you can do is you can think of natural log of 2 dividing by natural log of 2 can be rewritten as 1 over natural log of 2 times natural log of x. Right? This function right here is the same as this function right here. So what that tells us, natural log of 2 is just a constant, because 2 is just a constant. Therefore, natural log of 2 is just a constant. Therefore, 1 over natural log of 2 is just a constant. Right? This whole thing right here, 1 divided by natural log of 2, could just be plugged into a calculator and we would get some decimal number. So the derivative of some constant times natural log of x would be the same as this constant, 1 over natural log of 2, times the derivative of natural log of x. And that's just basically a property of taking the derivative of some constant times a function. It's the same as taking that constant times the derivative of that function. Well, the derivative of natural log of x is one of the kind of standard derivatives that you probably want to just memorize. It's going to be much more kind of complicated to explain how that derivative is actually figured out. What I would recommend is just memorizing it. Well, the derivative of natural log of x is just 1 over x. So this is going to be 1 over natural log of 2 times 1 over natural log of x, which is just the same as 1 over x times natural log of 2. So this is the derivative of this. Or I'm sorry, let's not go with that. Let's go with this. So natural log, or log base 2 of x, the derivative is 1 over x times natural log of 2. If you change your base here, that's just going to change whatever you're taking the natural log of here. So if you're taking the derivative of log base 10 of x, it would just be 1 over x times natural log of 10. So now what we want to do is, okay, so like I mentioned, actually, this formula is also one of the formulas on my study guide. But I wanted to show you kind of how you could figure that out instead of saying just memorize that formula. Generally, it's kind of a good idea to, have an idea of how these formulas are actually derived or figured out rather than just blankly memorizing formulas. So what we had here was log base 2 of x. Log base 2 of x, we figured out the derivative of that thing, back to our kind of product rule formula here, is 1 over x times natural log of 2. So we'll say g prime is 1 over x times natural log of 2. So the product rule says once we have our f, our g, our f prime, our g prime, we just need to multiply these across and then add those two products together. So the original of one times the derivative of the other one, the derivative of the first one times the original second one. It doesn't really matter what order you do these, right? We could do f prime times g plus f times g prime, or vice versa, as long as you're making sure to multiply the derivative of one times the other original. And same thing with the other kind of pairing. So if we're doing that, let's say we take f times g prime first. So we get x cubed times 1 over x ln 2. So y prime is going to be x cubed times 1 over x ln of 2 plus the derivative of that one times the original of this one. So 3x squared times log base 2 of x. Okay, so now we can simplify this a bit. So we have x cubed, and then we're dividing by x right here. So this x is going to cancel with one of these x's, just giving us x squared. And then we can multiply this onto the numerator here. So that gives us x squared over natural log of 2. And then over here, there's not really any simplifying to do with that piece. So it would basically just be 3x squared times log base 2 of x. And that's going to be the derivative based on the product rule formula. All right. I'm not seeing any questions in the chat here, so we'll go ahead and keep things going. Like I mentioned, if you are seeing anything that you have any questions on, feel free to throw it in the chat, the live chat. And again, even if it's not about product rule. All righty. So we're going to go over another product rule example here. We're going to find the derivative of 2 to the x times, all in parentheses, x to the 7th plus 2x minus 16. So again, with product rule, first thing you need to do is just figure out what are the two pieces that are being multiplied together to give you this overall function. Well, since we can see this 2 to the x is being multiplied by all the stuff within the parentheses here, we could basically just call the 2 to the x one thing. Everything within the parentheses here are other things. So we'll say this is f and this is g. Then again, we need to find f prime and g prime. So the derivative of 2 to the x, and this is another formula on my Calculus 1 study guide. Link is down in the description if you want to check that out. But the derivative, if you're taking any constant raised up to the x power, the derivative of this is always just going to be ln of a times a to the x. So, you know, a kind of very specific example of a constant raised up to the x that we see a lot is the derivative of e to the x. Well, the derivative of e to the x is just e to the x, right? It's a unique function where it is its own derivative. But that actually aligns with this formula here, because think about if we were to kind of use this formula instead, the derivative of e to the x would be ln of e times e to the x. Well, ln of e, the natural log of e, is just 1. So this is just 1 times e to the x, which is just e to the x. So this formula still works even if that constant is e. We just get a very, unique case where we don't have this additional coefficient constant that changes the value of the function. But either way, that formula can be used to find the derivative of that function, where basically a could be any constant. As long as a is a constant and there's no variables in it, that's going to work. So basically the derivative of 2 to the x is just going to be natural log of 2 times 2 to the x. Okay, then we need to find the derivative of this other piece here. Well, the derivative of this piece here, we can do just using the power rule. So we'll take our power, bring it down in front, giving us 7, leave our x as x, and then minus 1 from the power, so 7x to the 6th. The derivative of a constant times your variable x is just going to be that constant, so the x will basically just fall off. And then the derivative of a constant is 0, so we're going to get plus 0, so that's not really going to do anything. Okay. Then, just like we always do with these product rule problems, then we can kind of multiply across. So the original of one times the derivative of the other the original of one times the derivative of the other, and then add those two things up. So you will get f, so 2 to the x, so y prime equals 2 to the x times, and now this is something I really want to point out here. Whenever your f or g or f prime or g prime is the sum of a bunch of different things, so in this case we have this term plus this term minus this term. Here we have this term plus this term. Whenever you have terms being added and subtracted together that make up your f or your g prime or whatever, make sure you always put parentheses around the entire thing. So let's go ahead and make sure that we're putting these parentheses around all that and around all that, because if we don't do that, this 2 to the x is not going to distribute like it's supposed to. Now our 2 to the x is going to be multiplied by all this. We're going to get 7x to the 6th plus 2, all in parentheses, right? So now if we were to think about distributing that, it would need to multiply to both of these terms. If you forget the parentheses, you might forget to distribute it, and then this 2 to the x will only be multiplied by this first term, and you'll end up with the wrong thing, because that's not the way it should work. Okay, so we multiplied g prime times f, then we want to add whatever we get from multiplying f prime times g. So we'll get natural log of 2 times 2 to the x times all this in parentheses. Okay. All right, and okay, so before we go on to the next step here, if you guys are getting value out of this video, please do me a huge favor. Go ahead and hit that like button down below. So I know you're getting value out of this and learning something from it and enjoying this topic. Anyway, so the next step at this point really, the only thing really to do at this point, and this kind of depends on where you're going with the problem, right? So like in this case, we're just being asked to find the derivative. If this was a part of a bigger problem where we had to find this derivative of this function and then do something with it, it might tell us what form we want to get this to. And what I mean by that is it going to be easier for us to factor stuff out or distribute everything throughout the parentheses? Because those are obviously opposite processes, right? So we could like distribute 2 to the x into the parentheses here, distribute the natural log of 2 times 2 to the x into these parentheses, and expand everything out. Or we could do the opposite and look for common pieces between this thing here, that is the product of these two things, and this thing here, which is the product of natural log of 2, 2 to the x, and what's in the parentheses. So we have a product of 3 things here, a product of 2 things here. Look for commonalities and factor them out. If we're just trying to get our answer in simplest form, probably that second option is going to be what we would want to go with. We want to factor stuff out. So we can see that both of these terms here have 2 to the x in common, right? We have a 2 to the x right here and a 2 to the x right here. So what we can do is we can factor out 2 to the x from this. So if we factor out 2 to the x from this first term, we're just going to be left with what's in the parentheses here. And if we factor out 2 to the x from here, we're going to be left with natural log of 2 times all the stuff in this parentheses. Right, so this 2 to the x is now being kind of distributed to all the stuff within here. So this would probably be, the fully factored out version, as simplified as we could get it. I would probably just leave it here. Like I said, though, depending on context, you may want to have done the opposite and distribute these 2 to the x's into the parentheses. And that really just depends on what's going to be easier next. In this case, finding the derivative is all we had to do. This is as far as we're going to take it. There's really nothing else to do here. So that'll be the answer for that problem. All right, still not seeing any questions in the live chat, so we'll keep it rolling here. We got another product rule example to go over here. So let's go ahead and scroll on this way. We're going to differentiate y equals cosine of x times tan of x times x squared plus 1 in parentheses. So this is a little bit of a trick question I wanted to throw in here. There's a couple ways we could approach this. One is going to be much easier than the other. So I wanted to just kind of bring that up. What we could do is we could use the product rule basically when you have the situation where you have the product of three functions, like we have here, we can use the product rule multiple times to find the derivative where we basically want to treat like this three functions, f, g, and h. So like, and I have made a video on that. If you want to check out that video, I'll go ahead and put one of those little info cards up at the top on how to apply product rule multiple times to a function that is the product of more than just two things. However, we don't have to do that here, because let's think about this function for a second. Cosine of x times tan of x, specifically, let's think about that little chunk of it. Think about what tan of x is. Tan of x can be rewritten as tangent of x can be rewritten as sine of x over cosine of x. Okay? Those two things are equivalent. Tan of x is the same as sine over cosine. So that, first of all, that's a formula that I would definitely recommend memorizing. Remember that. Because it does come in handy a lot of times to simplify trig type problems. So this is always going to be true, right? No matter what x is. I guess the only case you want to be careful of is it doesn't really matter if you're taking if cosine of x equals 0, because then you're dividing by 0. However, tan of x is not defined at those places where cosine of x equals 0. That's where tangent has vertical asymptotes. Because if you were to think of this substitution here, you would be dividing by 0 there, so therefore it can't possibly be defined. So I guess it still kind of holds up there, but you just want to be careful that it doesn't really help in those specific spots. However, if we want to think of the function as a whole, we can say this is going to be true. So basically what that means is the function we're trying to find the derivative of here is actually cosine of x times sine x over cosine x times x squared plus 1. Well, now look what happens if we have cosine of x times sine of x over cosine x. The cosine x and the cosine x cancel each other out. So actually this function should not be thought of as this thing that we started with. Instead, let's think of it as sine of x times x squared plus 1. So now this is much easier to find the derivative of, because now we can just go ahead and proceed with the product rule, where one of our things is sine of x, and our other thing is x squared plus 1, and go from there. So let's go ahead and do it that way. So we found our f and our g. Now we need to find our f prime and our g prime. F prime is just the derivative of sine x. The derivative of sine x is cosine x. The derivative of x squared plus 1 is just power rule. Bring our 2 down in front. Lower the power by 1. 2 minus 1 is just 1. So that's just 2 to the x. And then the derivative of a constant is 0. So that would just be 2x plus 0. Well, that's just 2x. Okay, so now the product rule, again, is just going to tell us now that we're going to multiply across. So we do the original of 1 times the derivative of the other, the derivative of 1 times the original of the other, and then add them together. So doing that, we're going to get sine of x times 2x. So y prime equals 2x times sine of x. And multiplication, the order can be switched. So sine of x times 2x is the same as 2x times sine of x. Okay. Then we multiply cosine of x times everything in the parentheses here. And like I said in the last example, if you have adding and subtracting within a specific piece, like g is x squared plus 1, we have this addition here, make sure you keep your parentheses around the whole thing. So cosine of x needs to be multiplied by x squared plus 1 in parentheses. Otherwise, the cosine x wouldn't distribute like it's supposed to. Okay, so now, again, we kind of want to think of where we would go from there. Do we want to factor stuff out? Do we want to distribute stuff into the parentheses? We'll go ahead and say that we're just trying to kind of write this as simply as possible. So I would factor stuff out. But if we look at these two kind of products that we have here at this point, there's nothing in common between them. There's nothing we can actually factor out of that. So this is really going to be as far as we're going to take this, and that'll be the derivative of our original function. All right, still not seeing any questions in the live chat, so we'll go ahead and wrap things up there. If you got some value out of this video, do me a huge favor, go and hit that like button down below. If you want to check out my differential calculus cheat sheet, Calculus 1 study guide, or my complete Calculus 1 package, links to both of those are down in the description or in the pinned comment below. Hope you got some value out of this. Appreciate you coming and watching the video, and hope to see you next time. Thanks, and have a good rest of your week.